Let's try using R to approximate the solution to this problem. In this problem, we're sampling components from a bin, rather than repeating a process like rolling a die or flipping a coin. Because of that, I'm going to start by creating a vector that replicates the components that are in the bin. I'll do that by using the c function, which is a lowercase c, to create a vector. I want this bin to have 3 components from supplier A, 4 from supplier B, and 5 from supplier C. I could do this by letting the number 1 represent supplier A, 2 represent B, and so on. Or I could put double quotes around the letters. Now I have 5 copies of the letter C, 4 copies of the letter B, and 3 copies of the letter A. I'll want to store this vector in a variable. Next, we're going to randomly select 4 components for testing. That's our probability experiment. In order to approximate the probability, we'll want to repeat this multiple times. But to build my code, I'm going to start by thinking about doing this just once. I'm doing a random sample, so I'll use the sample command. I'm sampling from the bin vector that I've just created. And I want to sample 4 objects. If we're testing components out of a bin, it makes sense to me that I would want to draw 4 objects and then test them all, rather than pick one, test it, put it back in, and mix the bin up before drawing another one. So I'm going to do my sampling without replacement. And I'll want to store the results of this function in another variable so that I can work with it. Let's call it my sample. What's the next step? Well, we're interested in the probability that each supplier would have at least one component tested. So I want to check whether the letter A is in my vector, my sample, whether the letter B is in the vector, and whether the letter C is in this vector. If it is, then I'll count this as a success. So I'm going to use 3 if statements. The first if statement will test whether the letter A is in the vector my sample. I'll do this by using the %in% function. But I don't want to count this as a success right away inside this if statement, because I'll only have a success if all 3 of the letters appear in the vector my sample. I could do this either by creating nested if statements, or I could use an ampersand to create AND statements within the parentheses of a single if statement. Both of these would work. If we're using multiple if statements nested together, I like to put a comment at the end of the curly bracket for each of the if statements to help me keep track of which curly brackets are supposed to go with which if statements. That makes it easier to debug my code later if there's something wrong. Only if we pass through the first if statement, it's true that A is in my sample, and the second if statement, it's true that B is in my sample, and the third if statement, it's true that C is in my sample. Only then will we count this as a success. Remember to initialize success as being equal to 0 before the start of the experiment. Now I've written my code to perform this experiment once. It's a little bit complicated, so I'm going to copy this into R and check whether this code works before I try repeating it 1,000 times. Oops, I had an error that says argument 13 is empty. That's complaining about this comma at the end that says there's nothing after this comma. So I'd better delete that before I can run my code. I'm not too worried about this second error message because it's complaining that it couldn't find the variable bin. But that's happening because there was an error in the previous line where I was trying to initialize the vector bin. So that error will probably go away once I correct my error with the comma. Let's try this again. I didn't get any error messages. Let's see what the vector or the variable success contains. It contains a 1. Let's check the vector mySample and see if it really was a success. Yep, looks like we have 1A, 1C, and 2 Bs. So this would count as a success for this experiment. Everything seems to be looking good, so let's go ahead and enclose our experiment inside a for loop. And after the for loop, I'll compute success divided by 1,000 to find the estimated probability of having a success. I find that the probability of success was approximately 0.544. If I copied the code again, I would get a slightly different probability.